So let's start, guys. Good evening, everyone. As I have told you to do an assignment, how many of you have did the assignment? Just raise your hand. Or if you have any doubt, just ask me by unmuting yourself or just write it down in the chat. I again repeat, if anyone have any doubts, you can write in chat or unmute yourself. Or and if you have done the assignment and you don't have any doubts, then raise your hands. Have anybody done the assignment that I gave you yesterday? I also provided the notes. If you have not done the assignment, then you can write no, we have not done anything. Just don't be silent and withdraw.
Ma'am, your voice is getting low.
Okay, now am I audible? Hello?
Yes, ma'am.
Yeah. So I asked that if anybody have done the assignment, then write yes. If not done the assignment, you can write no. There is no problem with that. Okay. Yeah, I see. Do the assignment. Okay, so many notes. Yes. See, guys, if you'll do the assignment, then you'll get the doubts, right? And then you can ask what to do next. I hope you don't have any doubts from yesterday's class. Hello. Guys, I hope you don't have any doubts from yesterday's class. Just
Ma'am,
see.
it's the first assignment now, ma'am. First assignment you can explain now, ma'am.
I
Tomorrow
have just
onwards,
sorry.
we will complete, ma'am.
Hey, I just
Today,
asked that if anyone have any doubts.
once you can explain it, ma'am.
Okay, I will explain it later in the class. Let's just complete today's topic. Okay,
Okay,
if
ma'am.
that's okay, then okay. Yeah. So today's topic is understanding about autoencoders and GANS. Can anyone tell me what is GANS? Just the full form. Do I need to repeat the question again?
Generative adversarial networks.
Yeah, that's correct. So today we are going to study about two type of things, that is autoencoders and one is generative adversarial networks. So
Okay,
let's
ma'am.
go to autoencoders first. Okay. So what is an autoencoder is, imagine you're trying to compress a large image file into a small size without losing much details. Like when we give input a large image file, then it reduces to smaller image file without losing much details, without losing important details. Okay. So but it doesn't stop at the images. It can compress any kind of data. Like an autoencoder is a type of neural network designed to learn efficient representations of data, often for dimensionality reduction or feature learning. Okay, what it does is, like if you give a audio clip, it will make if the audio clip is a very large size, okay, it will make it to smaller size without any disruption in the audio or without any losing of features in the audio. It works in an unsupervised manner, meaning it doesn't need labeled data. I hope you understand that, right? Uh, okay, so what an autoencoders contain is encoder, latent space, and decoder. Let me share you the image. Just wait for some few minutes. Yeah, I hope this is visible. Okay.
Yes, ma'am.
Yeah. So, autoencoders contain input layer, hidden layer, and output layer, or we can say latent space, or we can say bottleneck. Okay. Uh, I hope I'm audible, right? Yeah. Okay. So, the input layer, when we could come to input layer, it contains nodes which are x1, x2, x3, x4, x5, x6. Okay, this represent input features. Like we are what we are inputting, we are inputting features. Okay. Next, these could be any kind of data, pixel value for an image or a sensor reading. Okay. Can anyone tell me what is a sensor readings? It's a basic question, right? Or you can just write in chat. There is no problem in that. Guys, just you need to interact, right? I again repeat, what is sensor readings? Okay. So the sensor readings are basically the data captured by sensors. Okay. So what does this input layer do? It gives feature to the mechanism. Okay, features or the feature can be pixel value for an image or a sensor readings. The input layer passes the data to the next layer without any transformation. That means the input layer directly passes to the hidden layer or the bottleneck layer without any changing of the features. Now let's come to the middle layer, or which we can say a bottleneck layer. So this hidden layer contains neurons like A1, A2, A3 we can see over here. Now, why this is called a bottleneck? Because the hidden layer has fewer neurons. Here you can see comparatively in the input layer and in the output layer, we can see the hidden layer contains very less number of neurons. Okay, so forcing the model to compress the data. When a feature or when a data comes to the from input layer to hidden layer, it compresses it. It compresses it and it makes it more detailed. And again, it passes to the output layer. Okay. So the network learns the most important feature or patterns of the input data in reduced form. And this process is called encoding. Guys, please remember this line that the network learns the most important features or patterns of the input data in a reduced form. Okay, any data, any we can say features which is passed from input layer to the hidden layer, this data is compressed and reduced, and by that from that process, the input it what it does, it learns from it. Okay, the network learns from it, and this whole process is called encoding. For an example, if you are inputting any you can say an image size of 6 which represent x1, x2, x3, x4, x5 and x's, and it process through this data which and compress it in the three feature format, which is a1, a2, a3, and it gives the output. Okay, I hope you understand this much. Yeah, can anyone say what is encoding? As I explained you, can anyone tell me what is encoding? Write it down or you can tell me, okay? Guys, keep interactive. Can anyone tell me what is encoding? Or do you need me to explain it again? So, okay. What does encoding do? Uh, Hello. I hope I'm audible, right? So, what encoding do is that the network learns from the most important features or patterns of the input data in a reduced form. Okay. So, this whole process is called as encoding. Let's go to outer output layer. Output layer can consist of nodes like x1, x2, x3, x4, x5, x6, but these are the reconstructed nodes. Okay, so the goal of encoder is to reconstruct the original input as closely as possible. This process is called decoding, where the compressed data is expanded back to the original size. So we put the data over here, input layer, it goes back to the bottom leg, or we can say hidden layer, and it get compressed again. It come out from the input layer and it becomes it expands and becomes in the original size. Okay, so the key point here is the output should be as close as possible to the original input. The difference between the two is minimized using a loss function like mean square error. Anyone know mean square error? I hope if anyone knows it, like it's a basic Python small program. It's a basic Python program. What is mean squared error? Guys, you can write down, no problem in that. Okay. So, mean square error is a fundamental concept in statistics that and machine learning playing a crucial role, such as the metrics used to measure the average square between the predicted values and the actual values in the data set. Such as if you put a cat image over here and it needs to give out the cat image in very minimal changes, and that the difference between this image and this image is determined by mean squared error. Okay, so next let's go how does this mechanism work. So let's go from the encoding phase. We give input data x1, x2, x3, x4, and all the nodes are connected to these nodes, right? Each and every node is connected to the hidden layer. Then let's go to the bottleneck layer. This layer contains compressive data and holds the most essential features that are discrediting noises or irrelevant information. Any information that goes from here to here, it stores the relevant data. Okay. Next, when we go to the decoding phase, what this contain? The the compressed data is then reconstructed into x1, x2, x3, x4, x5, x6, attempting to recreate the original input. Okay. So applications of encoders is dimensionality reduction, similar to we can say if we give any as I have told you before in neural networks, when we give any kind of images, it transform it into it can transform it into a bigger image or smaller image like that. Denoising data, removing noise from the images or signals. Okay, data generation from the basic for more advanced architecture like variation encoders like uh, when it comes to data generation, a simple autoencoder can't do it, but the more advanced architectural autoencoder can do it. I hope you understand till here, right? Okay. So let's come to the next topic that we can say is generative adversarial network. I hope everyone understand this, right? Anyone have doubt till here? Just you can tell me. There is no problem. Okay. Okay. So the next topic is GANS or generative adversarial network. So generative adversarial network means it can generate completely new data that looks like the real thing, whether it's an image, music, or even human-like text. When we talk about generative adversarial data, it's basically tells us about how it contains different types of different two types of mechanism, which helps it to you can see here, which help it to make it more real, get a more realistic images. Okay, so as I have taught you, can anyone tell me what are two types of mechanism that is used in GAN? Anyone? Yeah, generator and discriminator. Very good. So when we come to generator, what it does, it take random noises as input and generate fake data resembling the real data. Okay, when you give a cat image, it just look after it and try to make it uh, more realistic and comparative to the real data. Okay, when it comes to discriminator, it takes both real and generated data and classify them as real or fake. Okay, like it's like a teacher. If you write an essay, if whether you have copied from others or not, a teacher can identify it pretty well, right? So what is the objective of this GAN? The generator creates the generator tries to create data that is indistinguishable for the real from the real data, whereas the discriminator tries to correctly identify whether this data is real or fake. That is the output of the generator. Okay, so how does a GAN work? So the generator creates fake data from random noises. Discriminator evaluates whether the data is real or fake, and then we do the loss functions, which are we can say as these are mathematical representations. Discriminator there are two types of loss. One is discriminator loss. One is generator loss. When we come to discriminator loss, it measures how well the discriminator distinguish from real from fake. Okay. When it comes to generator loss, it measures how well the generator fools the discriminator. Okay. Both the networks are trained simultaneously, improving each other's iteratively. Okay. I hope you understand this. Uh, till here, do you have any doubt? And should I explain this image? Okay. So let me, I hope this image is pretty clear to you. Yeah. Okay. So here you can see the left side. Okay. Here you can see the generator. Okay. So what does the generator do? It takes a random input. Okay, random input in the sense ki we can take any random picture. Okay, let's take a random picture. Then it tries to generate a fake image. Okay, so when this try to generate a fake image, it goes back to the discriminator here, right? So when it goes back to the discriminator, and discriminator takes the random input and the fake image that is generated by the generator, and it tells if this is real or fake. Okay, so like that simultaneously they get what we can say that they get practice of how to generator get practice of how to generate realistic image according to random input, and discriminator gets a we can say practice of how can we identify which one is false image and which one is real image. I hope you understand this, right? So let's talk about the feedback loop actually. Okay. After the discriminator makes its decision, it provides feedback. If the discriminator correctly identifies a fake image, the generator updates its method to create better and more realistic image next time. And if the discriminator incorrectly classify a fake image as real, then the generator succeed. Okay, and what it does, it continuous train. Okay, this feedback loop continues, the generator keeps improving its fake images, and the discriminator keep getting better at spotting fakes. Okay, over time the generator images become so realistic that the discriminator struggles to identify the difference. Then the key concept is adversarial training. That is, the generator and discriminator are in constant competition. Who can fool whom? Okay, the generator wants to fool the discriminator, and the discriminator wants to correctly identify the fake ones. So both the network improve over time. The generator learns from the discriminator's feedback and create more realistic images, whereas the discriminator learns from the mistakes to become better at identifying real and fake. So can anyone tell me where the generator is used? Anyone can tell me where the generator, like any example of this particular mechanism? Hello, I hope I'm audible, right? Okay, Instagram, yes. Anyone else? Okay, let me ask you one more question. That does AR use GAN, like augmented reality? Have anyone heard about it? Augmented reality, or we can say virtual reality and augmented reality. Yes, yeah. Okay. So text to image synthesis. We use GAN, right? The generating image is based on users provided text description. Okay. And we can say live image editing, generating realistic alterations to live video streams. Uh, for an example, changing backgrounds, adding objects, modifying spatial features in real time, maybe mid journey. Okay, we can say yeah, but it's a AI, right? It uses GAN, but it also uses one more thing that is a bit higher of GN. Okay, I hope you're clear till here, right? Anyone have any doubt? Let me just stop sharing this. Anyone have any other doubts related to okay. So shall we do a Q&A? Then I'll teach something more about GAN and okay, yeah. So, how do encoders handle overfitting? Do anyone know about what is overfitting? I again repeat, do anyone know about what is overfitting? If no, then I can explain you. That's okay. Okay. Only one no. I guess everyone else know what is overfitting. Guys, you can write. There is no problem in writing. Okay. So overfitting happens when a model learns not just the underlying patterns in the training data, but also the noise and random fluctuations. For an example, you are giving a blur image. What if the image comes, the output comes out as same blurry and some distorted? That is overfitting. So in simple terms, it's like memorizing answer for a text instead of understanding the concepts. Okay, I hope now you understand what is overfitting. And my question was, how do encoders, autoencoders, handle overfitting? Okay, so let me tell you the answers. Okay, by compressing, yeah, very good. That's the right answer. By compressing its size. As we compress the size, we keep important details and we discard the details that are unnecessary. Okay, so which forces the model to learn the most relevant features instead of memorizing the data. Okay, so my next question is, what is the difference between GAN and an autoencoder? I again repeat, what is the difference between a GAN and an autoencoder? I want everyone to give one answer, okay? Like, don't give at a time answer, just one answer is enough. Cannot compare the real and fake, okay? Autoencoders cannot compare real and fake. What else? Simple example, noise removing. Guys, be a bit more clear, right? So I can understand which features are you telling about and which one. For, is it about GAN or is it about autoencoder? So let me tell you one of the feature, that is architecture. When it comes to autoencoder, it comprises of two things. That is encoder, compress the data, decoder, reconstruct it. Okay. When it comes to generative adversarial network, generator creates fake data, whereas discriminator distinguish between real or fake. Right? Okay. Training process. So yeah. Generative adversarial network has a training process, but autoencoders doesn't have any training process, right? So we can say output for autoencoders is reconstructed version of input. Okay, but when it comes to GAN, It's new, realistic looking data samples. What can be output quality of autoencoder? Can anyone tell me? Okay, so output quality of autoencoder may be blurry or less sharp, but when it comes to GAN, it can often be highly realistic and detailed. Okay, why it can be highly realistic? Because as generator creates fake data and discriminator distinguish between fake from real data, fake from real data, so it get trained. Okay, so next let's learn about different types of autoencoders and different types of GAN. I hope I'm audible and you know. Hello. Yeah. Okay. Guys, please give answers. Right. It would be easy for me. So there are different types of autoencoders. Let me tell you about some type of autoencoders. One is denoising autoencoders. What it does, it works on a partially corrupted input and trains the recovered the original undistorted image. Okay, as mentioned, this method is an effective way to constrain the network from simply copying the input and thus learning the underlying structure and important features of the data. Basically, what denoising autoencoders does is that it works on partially corrupted, like the uh, the input is half corrupted and half it's perfectly fine. Okay, then what it does, it trains to recover the original disorder. Like if you give a blurry image, less blurry image, then what it does, it scan it. Okay, it sees that what the features can be extract, then again it trains on it and it gives us a undisordered image. Okay, like that, there is a autoencoder. So this type of autoencoder typically contains more hidden units than the input, but only a few are allowed to be active at once. Like as I have told you, autoencoders contain a hidden, you can say hidden layer, right? So this autoencoder particularly contains a lot of hidden nodes, but only few nodes can be activated at once. Okay, like that when it comes to variational autoencoder, as I have said, it is a strong autoencoder and it makes assumption about the description of latent variable and uses the gradient variational bias. So this could be a big most probably it's a mathematical, contains mathematically things. Okay, like conditional properties and you can say it contains generative like directed graphical models. Okay, now let's come to convolutional autoencoders. There are this is one type of autoencoder that use convolutional neural networks. Okay, now one question is, what is convolutional neural networks? I have taught you yesterday, so I hope you know. Anyone? What is convolutional neural networks? Guys, I have taught you yesterday. Anyone? You can write it down. Okay, let me simplify it. What is CNN? I hope you remember what is CNN, right? Okay, so convolutional, okay, use filter to detect, yeah, it's use filters to detect an object. Convolutional neural network is highly effective at image classification, object detection, and image segmentation by using filters and detect important features like edge, texture, and shape. Okay, it has the features of shape, color. Yeah, right, right. So now let's come to the next part, uh, which is different types of GAN. So one is deep convolutional GAN, which use convolutional layers for image generation. The other one is CGAN, which is conditional GAN that adds labels to guide the generation process. Another one is cycle GAN that translate image from one domain to another domain. We can say turning summer images into winter images, like increasing or decreasing the warm tones or creating any color gradient. Okay. When it comes to WGAN, it uses Western distance for more stable training. Okay, this all uses mathematical things. Okay, so we can say this contains loss functions. This contains other mathematical representations. So can anyone tell me what are the application of autoencoders? Where can we use autoencoders? Anyone? Okay, can we use autoencoders in image denoising? Right, we can use autoencoder. Yes, we can use autoencoder in image denoising, in data compressions. Okay, dimensionality reduction also. Image recreation, yeah, we can use it. So, what the applications of GAN? As I have told before, text to image synthesis. Can image generation done by GAN? Pretty naive question, I guess. Yeah, image generation can be done by GAN using what, any a mid journey? And what can be other types of chat gpts? Chat gpt to use GAN? Anyone? Or any you can say AI that you know? I think. Okay. Or what can be the other, what we say, other AI that use GAN? Any idea? Okay, we can say, guys, any idea what other thing? Deepfake technology. It is used for videos and all. So that use GAN. Okay. So now let's come to what we can say. Should I ask some more questions? You can answer in yes, no, anything. Or should I go for the assignment part? Okay. So can anyone tell me what are common challenges faced while training GAN? I repeat, what are common challenges faced while training GAN? Guys, be fast. We need to see the assignment part also. Any one challenge you can write. There is no need to write all the challenges. Okay, so as the generator produces a limited variety of outputs, even if the input is noisy, okay, balancing and training both networks at once. Okay, yeah, that's true. We can say the GAN might get collapsed because of so many generated pictures. It gets stuck generating the same or very similar samples, right? Okay, so now let's see the assignment. Okay, let me share this. I hope my screen is visible to you, right? It's visible, right? Okay, so the question is, build a simple autoencoder using the MNIST dataset. The dataset I have just I have used yesterday. So that using that dataset, you need to train it to compress and reconstruct the images. Then test it on a noisy data to see how well it denoise the images. Okay. So let me explain you the code over here. As you can see, the we have taken libraries as NumPy, Matplotlib, TensorFlow.keras dataset for downloading this dataset, MNIST dataset. Okay. Now let's go for loading the MNIST dataset. As I told you, it contains x-axis and y-axis, but right now we are taking only x-axis. One is to train and other one is to test the dataset. Okay. So, okay. Yeah. So first we need to add noises. So add Gaussian noise to the image to test the autoencoder denoising capability. Okay. Then clip the noisy image to ensure pixel values remain in the range of 0 to 1. Okay. Now we need to build autoencoders. As I have told you that this particular dataset contains the pixel height as 28 into 28. So we need to make it into 1D, which is 28 into 28, which is 784. And that is a flattened image, and we can make it into 784 nodes. The input layer contains 784 nodes. Then the encoder layer reduces the dimensionality to 64, using ReLU activation, the decoder layer reconstruct the image back to 784 dimension using symphoid activation. Okay, now we need to train the autoencoder. Here you can see how we have built the autoencoder first, then we are giving autoencoder layer, then auto decoder layer, then compiling the autoencoder and decoder over here. As we have compiled it, now it comes to train the autoencoder. Okay. So while training it, we use a noisy image as input and the original clean image as targets. Okay. So first, as you can see, epochs over here, right? So we are taking 50 epochs with batch sizes 256. I have told you what is epochs. Can anyone write down or say me what is epoch? I repeat, what is an epoch? As I have told you before. Can anyone tell me what is epoch? Here, as I have written, it is the complete passing through of all the dataset exactly at once. Okay, so the dataset will be running 50 times. Okay, what is the batch size? Guys, write it down, or just if you don't know, then you can tell me that you don't know. I will tell you again. Yeah, batch size is 256, but what is batch size? We can say that the batch size is how much the dataset will be divided into how many batches. Okay. So after this, as we have written epochs is 50, batch size is 256. The next thing is predict on the noisy test image. Okay. We need to predict on the noisy test images. Then to plot the result, let me show you how the result will look. Just wait a second. So guys, here you can see, right? It is running 50 epochs. Okay. So one epoch is completed. See, here is a batch size, right? 2 epoch is completed, 3, 4, 5. It will run up to 50. Let's wait for some minutes. I'll tell you. Here you can see, right? And guys, try to do the assignment. It will be beneficial for your project, right? So here you can see 24 epochs are completed. So let me explain you this part. So first we have given the display original plus noisy image. Okay. Then reconstruct the images. Then display original and clean images. So it will be displayed in a what type of format? It will come in a window format. Okay. Let me show you. Yeah. Guys, can you see this window? Okay, wait. It might not be visible to you. Just wait. Yeah. Can you see this window? If yes, then you can just write down yes. Yeah. So what do you see in this window? It contains noisy inputs, right? The inputs are very noisy. Do you know what is this? No. Can you see what is this? No. Can you see what is this? No, right? Then it gives denoisy output. Okay. First denoisy output, then like denoisy output in the sense ke this is the original images. Okay. We add noise. First we add noise, then it denoise it. So you can see how it is matching to the original output. 5 is not clearly visible, but we can see it's visible. So what does it tells? It tells it gives output at once, but when it comes to GAN, it doesn't give output at once. When you will run the same code in GAN, it will give you still the noisy effects. It need to be run many times to give you a perfect crisp images. Okay. So guys, do you have any doubts on this particular part? Any doubt? Guys, let me ask you one more time. Do you have any doubt on this particular part? No, okay. Okay, so the task for, you can say, you have a lot of time, right? I've given you one task, right? You can just, like, I've given you one task yesterday. So you can just search those tasks, and I'm giving you two more tasks right now. Do it and show it to me in the next class, okay? I have told you already how the auto encoder tasks work. Now you need to do same for GAN task, right? So what do we learn from today's, you know, today's session? That when it comes to autoencoders, which are powerful tools for data compression and anomaly detection, and GANs, which are changing the game in generative AI, such as takes it takes multiple training session to train them to achieve a crisp image. Okay. Uh, so let me ask the team so that they can take. You all need to submit me the, you can say, the code and the result attached in a page. I'll ask the team to give you the format. Okay. So submit me before the class. So I will tell you what are the, you can say, what are the mistakes in it. Write it by own, or you can take help of Google, but don't use ChatGPT. Okay. So write it down. Just learn how to write coding in Python, or if you want any session in Python, any Python, then let you guys talk to the team. Okay. I hope I'm clear about today's class. Guys, I have just pinned the two tasks. So right now you have three tasks. Two is from today, and one is from yesterday. Hello. So, do you have any doubt? Any kind of doubt? So, let's end this session. It was a nice session with you guys. Just try to be more, what we can say, interactive so we can learn more. Okay, that's it for today. Complete your assignment and show me before the next session. Okay, thank you. You may leave.